All right, so in this example, we are trying to find the derivative, albeit the notation is slightly different. I'm using a prime instead of a ddx. We're trying to find the derivative of this product of this quantity and this quantity. Okay, so we have 4 over x to the fourth minus 1 over x in the first quantity. We have 3x squared minus 1 over x to the 2.1 power in the second quantity. Okay, so how do we go about doing this? Use the above strategy. Derive the first, copy paste the second, copy the first, derive the second. But before we do that, we need to manipulate this a little bit algebraically because we need to use the power rule to make this happen. So notice we have a lot of x's in the denominators. We want to get those up to the numerators in order to use the power rule, just like the power rule practice that we've done in previous lessons. So how do we manipulate this before taking the derivative? I'm putting this thing in a giant box that says take the derivative with the prime that I mentioned before. So we're just going to bring everything up to the numerator. That's all we're doing. So if you bring it from the bottom up to the top, the power becomes negative. So 3x squared, that's already there where it needs to be. Then we have x to the minus 2.1 here in the second thing. Then we are going to derive it with that prime. Now everything is where it needs to be. Power rule basically makes this sucker very, very easy. So let's go to town with that. Derive the first. So you have 4 times minus 4 x to the minus 5, subtracting 1 from the exponent. So we brought the minus 4 down, multiplied it to the 4, then subtracted 1 from the exponent. Then we're going to do the same thing here with this minus 1. We're going to have a minus 1 x to the minus 2. So that derives the entire first factor. Second factor, copy paste. That's all we're doing. Then add, then copy paste the first. So we have 4x to the minus 4 minus x to the minus 1. And then we have to derive the second because it's the second term. So deriving this 3x squared, that's 6x minus 2.1 in front, x to the minus 3.1, because we're subtracting 1 from the exponent. Okay, so that's that. We've successfully derived this. If you like, you can just say, I'm done, because all this problem asked you to do was derive. But let's simplify some stuff a little bit, like at least combine the coefficients so that your professor or teacher has a little less to look at. So we have 4 times negative 4, that's minus 16. Then we have x to the minus 5th. Then we have minus 1. That's just positive 1, or just plus in this case. So plus 1 or just plus. And then x to the minus 2. Then in the second term here, nothing really changes because we didn't do anything to it. And then, okay, now over here, we didn't do anything in this first term, so we'll just copy paste that loveliness. And then in the second term, we have 6x minus 2.1. So that's plus 2.1, right? X to the minus 3.1. And then in your final step, if you really want to, you can take all your negative exponents, put them in the denominator, and make them positive. So let's do that just for funsies. So that handles the first term. Second term, 3x squared minus 1 over x to the 2.1 with a positive exponent, then plus 4 over x to the fourth minus 1 over x times quantity 6x plus 2.1 over x to the 3.1. Ta-da! Very straightforward. You could have stopped at the first checkpoint. I prefer to stop at the second one just because I like having things in the denominator. And before you ask, no, I do not force my students to do that. I would be very happy to stop them at the first checkpoint. So I'm kind of, at least maybe nice in that respect.